Yes, good morning, fellow alumnus, my dear friends, ladies and gentlemen. Today is truly a red letter day for us at Annamalai Alumni Business Network. It marks a magnificent milestone in the annals of AABN's Sunday webinar outreach programs since we have hit the magic number of 200. And to mark this memorable day, we have one of the most inspiring self-made icons from the corporate world. Dear friends, please join me in welcoming the one and only Dr. Madhukar Garg, a mentor, a role model for entrepreneurs, and a thought leader. Dr. Garg, as he is respectfully referred to in the corporate circuit. Dr. M.O. Garg is a well-known face in the oil industries of not only India but also in the global arena. A chemical engineering graduate from LIT Nagpur, he went on to do masters and doctorate from Australia to equip himself to be a specialist in both extraction process and pinch technology. While extraction helps recovery of useful compounds from any given mixture of liquids, the pinch technology helps to optimize the energy use in any process. These two are widely deployed in oil refining. Some of Dr. M.O. Garg's contemporaries in oil sector recall his excellent contribution in advanced process controls, development of Barox catalyst, preparation of first biofuel as substitute of aviation turbine fuel, effective diagnostics to enhance process reliability, apart from several extraction-related studies and solutions to the industry. In 2014, the Make in India scheme was launched to improve India's manufacturing prowess and open more vacancies for employment. The core goal of this scheme was to support the indigenization of technologies. In today's world, where there is cutthroat competition between countries with respect to economy, technology plays an important factor in improving the rate of growth. But what is even more vital is that the men behind the machines can comprehend the technology. Therefore, indigenization of technology and shifting to new technology are one of the foremost priorities of the leaders across the globe who want to see the nation prosper. Indigenization is a crucial step for a developing economy to transform itself into a developed economy. Hence, it holds huge economic significance. With the increasing globalization, more and more men and material resources are being available for the foreign nations to utilize for the benefits through bilateral ties. This leads to underutilization of its own resources by the nation to develop itself. Using of own natural resources is cheaper and easy to harness. Today, the talk by him on the path-breaking initiative of benzene extraction from hard cut of FCC gasoline is the jewel in extraction technology to be developed and deployed in such massive scale commercially. I am sure the participants will be bubbling the ideas to seek his advice and support in shaping up niche technologies in your respective areas. Let's listen to the efforts done by him as the then director of Indian Institute of Petroleum, Dehradun, when the benzene extraction whole process was steered by him. There's so much to Dr. Garg's achievements and journey. I'm not sure it can all be summarized in the limited time in the session. So without delay, I would like to open the floor to the one and only Dr. Garg, whose hard-hitting experiences are bound to inspire and guide you. His is the story of a dream that turned into reality only because of his passion and grit to take the plunge. It's a story of the trump of hope and hard work, ideas and innovation. Once again, a very warm welcome to you, sir. We are truly privileged to have you deliver this special address today. Thank you, and over to you, Dr. Garg.
Thank you, Gopiji, and a very good morning to all. I never expected that I would be addressing such a intellectual group, but it's my privilege and an honor. And before I begin, a very happy New Year to all of you. I hope I'm audible, visible, as well as you can see my screens.
Yes, sir.
All right. How much time do we have, Gopiji?
Say about, you have about 1.5 hours, sir.
All right, that's good enough.
Yes.
Well, actually, when
200 webinars
a very dear friend of mine, Shri N.S. Murthy, I'll tell you the background how I got into this. In fact, Murthy ji called up and he said, we have this forum and whether I would like to talk anything, you know. I thought about it, and I think this particular technology that we developed and commercialized in Reliance perhaps actually represents the real Indian ethos in terms of being challenged and to be able to come up to the expectations a very challenging expectations and then make it successful. So this presentation not only is technical, but also actually largely covers the attempts and the efforts that were required to start to take to actually initiate something from scratch, literally from scratch, and take it to the world's largest unit and first of its kind technology in India, and that to for a very demanding client like Reliance. Uh, well, actually, the title Gopiji has already talked about. Let me tell you, I mean, the next 45 minutes or so, we'll talk about how the real business need resulted into the requirement of having such a technology, where we'll talk about the drivers basically. The second is the process development itself, and that's a quite a journey. In fact, all the way from starting lab experiments to complete process design, and then the process design and engineering by itself. Let me see if I can get a pointer here. Uh, okay. I think I need to put it on the, yeah. Okay, so process design and engineering, and then finally commissioning operation, and we also actually ended up doing what is called as a GTR, guarantee test run. Well, let's talk about the business need. Way back in 2011, the US actually decided to reduce the benzene content of their gasoline down to 0.62%. As you know, across the world and more so in India, we have Bharat Stage 6, which is equivalent to Euro 6, and the specification of benzene. Earlier in our gasoline, there was hardly any specification, and then it went down to 3%, 5%, then down to 3%, and now we are down to 1%. Japan and Europe and South Korea, of course, is 0.7. So roughly around 1% is the specification of benzene in FCC gasoline, in gasoline because of its carcinogenity. The US actually took the initiative under the MSAT 2 regulations to reduce it down to 0.62%. At that moment in time, Reliance, as you know, has two of the world's largest FCC technology, FCC units. Each one of them is about 200,000 barrels per day. And so a very large quantity of FCC gasoline gets into the gasoline pool. And when actually Reliance looked at the various streams which go into the gasoline pool, the gas plant of the FCC in Reliance is pretty exhaustive. And the de-isoxyanizer column side cut was was identified as the major contributor of benzene in the gasoline pool, roughly about 11 to 19%. So it was thought that if we can remove benzene from the stream, that would enable Reliance to meet the overall not only 1% for domestic consumption, but also 0.62% for export to the US. So, and also actually, Reliance thought that if we can recover this benzene and then sell the benzene, that itself would be like a bonus in terms of not only meeting the gasoline specification, but also to be able to sell valuable benzene as a petrochemical feedstock. Now, if you look at from a perspective of a person like me in liquid extraction or extractive distillation, if you look at the de-isoxyanizer side cut, first of all, it's a hard cut. It's a very narrow boiling range, 60 to 90 degrees Celsius. It is very high olefinic content, and I'll share the composition. The naphthenes and diolefins actually co-boil along with benzene, so making it very difficult to separate out benzene by just pure distillation. And so basically they form azeotrope. In fact, those of you who are knowledgeable about this area would know that benzene actually forms azeotrope with almost every hydrocarbon. And naphthalene and diolefins is, of course, for example, benzene and cyclohexane, they boil very close. A considerable amount of high boiling C7 components were there, as compared to conventional feedstocks to make aromatics. For example, reformate or pyrolysis gasoline, which is roughly about 60 to 80% aromatics or benzene in the mixture. This is a very lean feed, around 11 to 19% benzene. And to be able to recover pure aromatics from here is itself a challenge. So, and also in addition to that, this is actually straight out of the FCC unit without any pre-treatment. So this particular stream is highly rich in sulfur, oxygenates, and also contains chlorides. This is typically the composition of this dehydrogenized sidecar. As you can see, the range of composition do not actually vary a lot. It's only C6 and a little bit of C7. But it's very low in benzene. As you can see, it's only 15% benzene. This is one of the samples that we received at IAP. We received, of course, several batches of this material, but it's typical. The numbers will not vary too much from here, whatever you see. But largely what you see is that it has roughly about 36% olefins, which actually contribute to the octane in the gasoline. Paraffins is about 4%, isoparaffins 27%. This also is a octane contributor. Naphthenes around 17%, and there is of course C7 around 2%. More importantly, we have diolefins, which is roughly about 1.58%, and I'll come back to this in a moment. These are some of the impurities like oxygenates, sulfur, chlorides, as well as nitrates. So the options that were studied to begin with, was of course this was done by Reliance. This was the time when I was at IP. I'm talking about around 2011, 2012 time frame, about 12 years earlier from today. So this work actually at IIP, in fact, Murthy ji sent me a mail sometime around end of 2010, early 2011, asking us whether we can look at this feed to be able to achieve this objective. So this was some of the work which was earlier done by Reliance to be able to see if we can enrich, but to recover benzene just by simple distillation. But that wasn't possible, and so that was given up. And then, of course, the standard practice which actually the world follows is to hydrotreat this feedstock, followed by isomerization. But actually, you lose the benzene. Not only that, but you have a high capex and opex. So this was not something which was actually chosen by Reliance. So what was required, what was actually they decided was that this was when I was at IAB. So Reliance approached various licensors for this technology. A lot of them regretted. Only 2 licensors stated feasibility. One of them even competed during the project. But there was no proven technology. What I mean to say is that there was no operating plant operating to be able to recover benzene from this particular feedstock. So Reliance was convinced that we need to develop this technology because otherwise, I mean, no commercial existed to be able to handle this feedstock. So IAP, Reliance combined together as a fund team. I think I just talked to Abhishek Jha the other day. I think he might be also on the call. So there was a team formed between IAP and Reliance. What actually each one of them brought their own expertise on the table. Why I'm saying all this is because today or even 10 or decade ago when this work was done, there's not everything that you can hope to have in a single organization. So people have to actually synergize their strength. And this is a great example of that. IAP brought a lot of strength in terms of fundamental understanding of chemistry and also our proven experience in liquid extraction and extractive distillation, very large number of technologies developed and commercialized. Not only that, we also had state-of-the-art laboratory and pilot plant facilities. Reliance strength was that, as you know, very strong technology knowledge, commissioning and operating experience, process engineering knowledge, and very fast project implementation skill. So ultimately, this was combined to form one team, and this resulted in a very successful development, process design, engineering, construction, and operation of first to the world unit. And this still remains, by the way. I'm so glad to inform you that it still remains the only of its kind in the world, operating in our own country in Jamnagar. So this is how the whole thing happened. This is the full story. We already talked about the business needs. The next step was, of course, to do the real hard work in terms of, first of all, proof of concept, whether it will really work, the chemistry, the separation itself. And once we are successful with that, to be able to do pilot plant studies and scale up, and then process design and engineering. Followed by that, construction, commissioning, and operation of the commercial unit. So that's the full story that I'll walk you through it. So basically, the first, of course, is the proof of concept, as I told you here. And for that, we had to do laboratory experiments. I think there was an earlier talk from regarding sulfolane. In fact, IAP also has developed several sulfolane-based technologies at BPCL, Kochi Refinery, as well as fruit-grade hexane units. So we had large amount of knowledge and expertise and also confidence with sulfolane as a solvent. So naturally, it becomes quite easy for us to use sulfolane for doing the studies. And since actually IIP had a lot of expertise in liquid extraction, so we thought let us try solvent extraction, liquid extraction in particular. So we use something like solvent to feed ratio 3.25, temperature around 40, and this is what we got. What we got was this is the feed that we talked about earlier, around 14% aromatics and 39% olefins. And we have, of course, a beautiful 32 millimeter diameter packed extraction column at IAP, where we carry out a lot of technology development work, and the same was used here. And as you can see that the raffinate, which is the real product as far as this process is concerned, still has around 7% aromatics. That is about 7% benzene. So that didn't, that actually showed that liquid extraction was not going to work. And the extract has 64%, only 36% non-aromatics actually. So that actually does not meet the requirement of Reliance. And so we thought, since we have so much of olefins in the feed, which are of lower boiling point, and since the aromatic content is low, let us try extractive distillation. So what we did was we actually repeated, we actually carried out, we have a column called Oldershaw column. I can show you a picture later, but the Oldershaw column is a pretty industry standard to be able to, study difficult distillation systems. And not many people actually know about this column. It's a beautiful column which can be used, the data can be used directly for scale up. And I have no idea when we came, when we have, who and when this column was established at IIP. But everybody knew that we had an old Risha column, and that was the only in the country. In fact, after joining Reliance, I established one more older show column at our Reliance Corporate Park in the R&D Center. So now we have two in the country. And this column actually is a glass column, which is jacketed with silver lining. So it's completely, cold wall. And you can carry out distillation with various kinds of applications. So what we did was we used sulfolane 3 weight by weight solvent to feed ratio. And what we found was that there were thick deposits. There were real black. It's like curdling of milk, and we thought that this column has not been in operation for many, many years, almost for 3 decades. Nobody knew that this column, how to operate this column. So we actually, first of all, cracked that issue. We got everything going. And then when we found this sulfolane, this run actually not proceeding above 120 to 125 degrees Celsius, we actually opened up the column, cleaned it up with potassium dichromate, potassium permanganate, etc., and then we repeated the run again. Actually, we could not go up beyond 125 because of heavy choking due to deposit formation in the column. So in view of the above, we decided to carry out investigation on thermal stability. So what we did was LMG1 is basically the name of that, the acronym we gave to this feed, light motor gasoline. And so sulfolane, we mixed both of them and heated in a 500 milliliter round bottom flask. This is, representing something like a batch distillation, both on the air and nitrogen atmosphere. And what we found is that the color changed from light yellow to brownish and then became darker beyond 120. And at 140, we had dark deposits. We tried the same thing with straight on naphtha, just to actually see what will happen there. And with the color change, of course, from lightish yellow to brown, but we didn't see any deposits, actually really thick deposits. You can see these deposits here. And these deposits is perhaps due to the reaction of sulfolane with the olefinic material which is present in this feed. So this is like something you can see. And this can't work in a commercial distillation column with this kind of deposits actually. Then we used another solvent, N-methyl pyrrolidone, on which also we had large amount of data and experience. In fact, the fruit grade hexane unit at HPCL Mumbai refinery, we actually, changed the sulfolane to NMP. And this again, we did exactly the same way as we did with sulfolane, with various percentages of water also, and we didn't find any gum formation. It was the liquid was extremely crystal clear. So this was the summary. We actually tried many other solvents, including NFM, that is N-formyl morpholine, as well as dimethyl and so on and so forth. In fact, we also added 3-methyl sulfolane in sulfolane, which is actually a solvent which is used by one of the companies, one of the competitors. And in all of them, all sulfolane-based solvents, we black deposits, and the temperatures did not go over 120. While with NMP, NFM, and DNF, it works very well. But we decided to go ahead with NMP as a solvent. So what we did was, we tried a few experiments with NMP, and I'll talk about it later. But first of all, let me share the chemistry. And this is very interesting. In fact, at IIP, we had some very strong organic chemists, synthetic organic chemists, and we got them to actually think about what exactly happened, particularly with sulfolane, and why it doesn't happen with NMP. So this is where actually what they came up was that The conjugated diolefins, that means these are cyclic diolefins like hexacyclohexadiene and cyclopentadiene, and they actually react with oxygenates, particularly at the allylic hydrogen position, to form organic peroxides. And these organic peroxides interact with diolefins, especially conjugated diolefins, initiated polymerization reactions. And this is a chain reaction which happens. And this causes degradation of sulfolane, particularly at high temperatures. The reason is that the S double bond O, S double bond O bond of sulfolane, they are highly polar. And as compared to the lower bond strengths, as compared to the C double bond O, that is the carbonyl group in NMP. And so basically nitrogen-based solvents such as NMP, NFM, and DMF, they all have this carbonyl group and hence are much more stable as compared to sulfurine. And since the polarity as well as acidic character is much lower, they do not actually initiate the polymerization as sulfurine does. So this was quite well proven that, we kind of proof of concept established that sulfurine is not going to work. So we did some probe runs with N-methylpyridone. Initially, of course, we carried out a few runs on the Oldershaw column just to find out whether we will meet Reliance expectations at all. And the results obtained were quite encouraging. In fact, we were not only able to meet the benzene spec on the raffinate, but also got a reasonably pure extract. And based on this success, more than 100 runs were carried out, which is not something trivial with NMP as a solvent, by changing various operating conditions, like for example, solvent to feed ratio, solvent water content, reboiler temperature, reflux ratio, etc., etc. This Oldershaw column had 50 trays already in it. And so even the feed plate location, etc., were actually changed. And with every run, we carried out a complete detailed hydrocarbon analysis, the one that you saw earlier, and along with the sulfur content. One very important thing which I would like to mention here, and NSM, who is on the call, would actually recall that every time we did a run, we actually sent samples in vial to Reliance as well, so that they also do analysis at their end. And this was done in order not, it actually achieved it actually helped us a lot, not only to build a correlation between our analysis and Reliance analysis, but also confidence in Reliance to see what exactly was happening at Dehradun. And more importantly, if suppose our machine is down, that means our GCMS is down, at least we can get the data from Reliance. Actually, we carried out all these runs. Each one of these runs, we also looked at the material balance, and our target was less than 5% in terms of feed and the products. And to achieve the objective of the project, for example, benzene less than 0.2%, and sulfur less than 15 ppm, and benzene purity greater than 98%. So all these runs that we carried out and the parameters that we varied was ultimately to meet these three objectives. And then whatever data we got, we also reconciled the data to be able to meet not only the overall mass balance, but also component mass balances. And then the development of the simulation model. Just a minute, I think, yeah. So all this data was then used to actually develop a simulation model on Aspen Plus platform. As you know that the non-ideal liquid phase activity coefficient parameters in any of these commercial simulators do not actually represent the real world system accurately. So it only provides a flow sheet simulation. But we had to fine tune the component interaction parameters using the experimental data. A very large component data set out of those 106 runs was used to actually estimate these parameters. What are these parameters? Actually, for non-ideal systems like the one that we are looking at, because we are adding solvent which is polar in a feed which is non-polar. And that actually creates non-ideality in the system. What I mean by non-ideality is that the liquid phase activity coefficient is no longer 1. So the relative volatility between two components, A and B, is now not only fugacity coefficient into vapor pressure ratios, but also it's multiplied by the activity coefficient. And this activity coefficient, we have several thermodynamic models. These are called, solution theory. But the one that is proposed by Renault and Prausnitz in 1968, called NRTL, that is non-random two-liquid mixing model, is the one that actually is used very popularly in all these flow sheet simulators. But that needs actually estimation of several parameters that you see, like tau ji, tau ij, as well as alpha ij. What happens, this particular simple feed that you saw, boiling in the range of 60 to 90, already has 39 components, going right across various paraffins, isoparaffins, olefins, diolefins, naphthalene, and aromatics. And so 39 components, actually you get 39 by 39 matrix of tau ij, similarly 39 by 39 matrix of tau ji. Of course, alpha ij we normally keep 0.2. And so these parameters are required to be able to do a reasonable job of simulating these systems. And unless and until you are able to simulate on Aspen, you cannot actually scale up and do process design. So this was the most critical step in terms of enabling use of commercial simulator like Aspen, estimation of these NRTL parameters. So of course, in Reliance, in IAP, we had large amount of data already available for olefinic feedstock. So after doing the consistency check, this data was then used to estimate these parameters, some of which we didn't have time to estimate. We actually resorted to literature and Dortmund data bank, and ultimately fine-tune these parameters uh, with respect to the actual 106 runs that we carried out on the older shock columns. And these are some of the data that I'd like to show you. This is by no stretch of imagination the actual operating conditions in the commercial unit at Jamnagar. But let's say just gives you an idea as to the various the data that we generated, the kind of data that we generated for each of those 106 plus runs. So let's say the reboiler temperature 145, NMP containing 5.1% water. You can see that we were able to match the reboiler temperature reasonably well. This is the lab data of the raffinate. This is the simulated values. These are for the various components that you saw earlier, C5, C6 olefins. This is the olefins, these are the diolefins, the paraffins, the isoparaffins, naphthenes, and aromatics. And this is the extract, that is the bottom, the bottom of the column. And we are able to see, one thing you can see that we were able to establish the proof of concept reasonably well. Top raffinate is 0.12 aromatics, as well as almost 98% pure extract. In fact, when you go up on the reboiler temperature to 180 degrees with less water in NMP, you can see that we could even achieve 0.05%, which is 500 ppm. Benzene in the raffinate, so which is very high, very good, and around 97%. One of the major impurities which I would like to mention, which you cannot get rid of in the extract, in other words, you cannot make 99.4% type benzene, is because of the presence of C7 paraffins, because isoparaffins, which are actually because of the deisoxyanizer hard cut by itself, and the C6-diolefin. So these are the two major impurities which somehow remain in the extract. So some of your observations is that sulfolane is not possible for this kind of feedstock. Was a big, uh, a huge contribution made by IEP. It is saying that a kind of an industry standard kind of a solvent which cannot be used for this kind of an application. NMP, of course, proved very well. Not only that, we were able to actually remove almost the entire benzene from the feed and produce 98% plus pure aromatics. We optimize the various operating conditions. Based on that, we were now ready to do the process design. And here, of course, there were many requirements from the site that we need to maximize air cooling duty wherever possible, use of MP steam, minimization of solvent loss, avoidance of pressure below atmospheric pressure. That means not use vacuum in the solvent recovery column because of the fear of oxygen ingress, and to be able to maximize process-to-process heat exchange. So a detailed flow sheet was developed at IIP. Why I'm saying this is that here is a research lab in the CSIR umbrella, having the capability to even actually develop a flow sheet and a process information package. And this flow sheet was then simulated using the custom built simulation model that we established on Aspen. This is the process flow sheet that we came up with. It's a bit complicated, but let me walk you through it. It has two major columns. One is what we call as the extractive distillation column, and the other is the solvent recovery column. So we take the feed, that is the deisoxyanizer side cut, through a feed surge drum, and then pump it on the 41st tray or somewhere around that in the extractive distillation column. And we have solvent from the top, around 10th or 11th tray. The overhead actually is the raffinate, which actually condenses. We provided a trim cooler and then into the overhead drum. The part of it is, of course, reflux back in order to make sure that any of the solvent coming up gets washed down. And this is our major product. Almost 85% of the feed is this raffinate. The extract actually comes down from the bottom, which is now rich so this is solvent plus aromatics, goes into the solvent recovery column, where we use steam for stripping. And this actually then condenses, and of it is reflux back, and the water is then withdrawn. I'll talk about the water stream separately because although people believe that solvent is actually the bloodline of this unit, but personally, let me tell you that water is really a critical stream here. So the solvent is recovered and then recycled back to the column, to the extractive distillation column. The water actually from the boot of these two columns, we tried to keep these two waters separate. Because this water from the extractive distillation column is rich in non-aromatics, while the water that is coming from the SRC overhead is rich in aromatics. So we can try to keep them separately. The water from the SRC boot goes into a stripper where we strip out any of the dissolved benzene. We strip out any of the dissolved, sorry, I forgot the trace. Yeah, so we strip out any of the recovered dissolved aromatics and we put it back into the SRC overhead. While the stripped water we take to water wash the overhead of the EDC. This is to actually make sure that we don't lose any NMP. And this water then from the EDC boot is then sent to a separate water stripper where the non-aromatics which are dissolved goes back into the EDC overhead. And this water then, which is the combined water from both these columns, then goes into this steam generator and into the solvent regenerator and back into the SRC. So it's a very big water loop, a complicated water loop, which we actually innovated and invented and proved to work. In this flow sheet, there are large amount of process variables, and we carried out several simulations to be able to do an optimum combination of them. The number of stages to begin with, the feed and tray location, the optimum feed conditions, solvent inlet temperature, circulating solvent water content, reflux rates, SRC stripping, steam quality, etc., etc. The three major important variables: the solvent to feed ratio, the water content in the circulating solvent, and the reboiler temperature in the extractive distillation column. I think Gopi talked about my expertise in pinch analysis. Actually, so there was no way I could not stop doing pinch analysis on this grassroots unit. And those of you who have actually had some exposure to this would know that this is the composite curve, temperature versus enthalpy. This is the hot composite and this is the cold composite. And this actually is the heat requirement of this entire process. Well, this is the heat availability. And we looked at the grand composite curve as well, and we found opportunities for heat integration. Basically, there's one hot stream, there are many, many cold streams. That's what it shows. These are the various reboiler duties that we need to provide for. So we actually ran the hot circulating solvent through several reboilers, two side reboilers in the extractive distillation column. So you can see this whole thing rather than me talking about it. Let me actually walk you through it. So this hot solvent which comes out from the SRC bottom, we take it to run the stripper reboiler as also to heat up the feed to the stripper. Same thing with the other stripper, that is the SRC stripper. We take the same solvent to generate the steam, and also actually to be able to vaporize the feed. So we in fact not only preheated the feed, but also did almost 80% vaporization of the feed to be able to minimize the fin-fan cooler duty to cool the solvent down to the required temperature before it enters the extractive distillation columns. So this is what actually is listed here. So this technology that we developed, the entire development work was completed roughly around 2012. And we actually put out what I actually innovated. This is my personal innovation. This is what we call as a TIP, Technology Information Package, which is basically a complete flow sheet, heat and mass balance, a sizing of major equipment, etc., etc. And we actually provided that to Reliance to be able to do the costing, etc. So basically this summarizes the novelty and innovativeness of this technology. First of its kind processing operation. As I said, this is the first to the world application where the virgin feed coming from the FCC was directly processed before any pre-treatment. An optimum solvent for handling this feed containing various impurities such as oxygenates, chlorides, sulfur, and so on and so forth. Particularly to be able to handle the organic peroxide, we actually estimated this by the parameter called peroxide number. To be able to handle a very lean feed containing only about 11 to 14% aromatics, to be able to make almost 98% pure aromatics. So this is a formidable challenge which was overcome with careful and optimum selection of solvent and operating conditions. That was the technology part. Then came the flow sheet. Our innovation was to be able to have two separate strippers to be able to handle the water in a very closely, to not only minimize but also eliminate completely the loss of NMP. Rigorous simulation model was developed. This is actually the key to this whole technology, not only for simulating the whole flow sheet, but also to gain confidence of the client that something like this would work. Remember, there is no commercial unit in operation. The whole data is generated in a 1-inch diameter Oldershaw column. And from that data, we develop a flow sheet. And then, for a company like Reliance to be able to invest on a new technology where there was no commercial reference at all. Of course, personally, I have a lot of experience on data reconciliation and gross error detection. So we use these tools to be able to close mass balance and component mass balances, which was then used to actually cross-check with respect to simulation. Very innovative process configuration and, minimizing of energy in terms of pinch analysis and process integration. This actually looks like a simple picture to you. This is the US patent that we got way back in 2014. And in fact, the inventor, the assignees are both CSIR as well as Reliance. But it's a separate story about this patent. And of course, not only in US, but we got patents across all major economies in the world. A few more patents have been allocated in Malaysia, Singapore, and so on and so forth. European Union, we have validated in 6 countries, and India. So actually, it's a heavily patented technology with a date of priority of 9th August 2012. There's a lot of, uh, what I should say, struggle or which cannot be discussed in this kind of a forum. But I think for people who are actually into developing technology and also simultaneously competing with international companies to be able to push their technology in a company like Reliance, it's actually a pretty big learning curve. This particular effort, this one single page actually is a big learning curve for anybody to be able to achieve that great target. And this is, of course, the picture of the groundbreaking ceremony at Reliance for putting this unit. You can see NS Murthy somewhere here. And a very unique picture actually. Saini Saab, who was group president there in Jamnagar. He is conducting the groundbreaking ceremony. And so this was the commissioning of the unit. The unit was commissioned. I still remember that day. It was a Buddha Purnima day. And 23rd May 2016. So it was a full moon day. And we cut in the feed at 10 past 9. In fact, Abhishek Jha, I think he might be on the call. He was there, and then no incident, flawless commissioning. We had on-spec product in RTF in 48 hours. You can see me here turning the wheel, and Mr. Kapil, who was he's one of the directors, Bala, who was head of operations. We got 100% throughput within a week, and as we speak, the unit is operating at 150% the design capacity. In fact, this one single unit, this is the picture of the unit. We had this, the picture of the team. It's called D363, benzene recovery unit. And the plant has been in operation continuously since May 2016. And it has only been shut down last year, not last year, 2023, September, along with the FCC major shutdown. So the DTA FCC unit DTA means the old refinery. Shutdown happened in September 23, and that's when actually BRU, that is the benzene recovery unit, also was shut down. for maintenance. So it ran from 2016 to 2023, almost 7 years without a major shutdown. This is the team actually. You can see Abhishek Jha, I think, here, myself. And this is that one team that I talked about, IAP. We have Shrikant Nanoti, Samnil, Prasanji. These are from IAP, and Bala, and so on and so forth. Nautiyal, who is our chemistry guy. Sachin Punekar, who is now at Jamnagar. He's chief of operations. This is the picture of the unit. In fact, every time I see this unit, when I go to Jamnagar, you can't even believe how proud I feel when I see it. From a 1-inch diameter older shock column, this is 4.5-meter diameter extractive distillation column, 55-meter tall. This is the solvent recovery column. You can barely see the two strippers here. I think this is the one at the back. This is the reboiler, of course. This is a huge unit, actually, and very fortunate. It's actually on a corner plot on between the main road and the road going to the other part of the refinery. And these are the fin fan coolers, as you can see. We provided actually 3 feed entry points just to make sure that if suppose the decided location that we thought was both ideal doesn't work, then we can shift the feed location. This is the picture of the unit in the night. In fact, this is the first unit perhaps in Jamnagar which was provided with LED lights, and it was very well lit in the evening. A very large number of awards was given to this technology. To begin with, the CSI Technology Award in 2014, and the first ever Ministry of Petroleum and Natural Gas Innovation Award, which is given by Center for High Technology. The ICC Award 2016. In fact, Mukesh Bhai himself was there in that award ceremony in Taj Hotel in Mumbai. But the biggest thing, of course, was the TDP National Technology Day Award. This is the India's biggest award, carrying a cash prize of 50 lakhs. And this was given in 2019. Of course, physically, we could not get this because this award is given every year on 11th May. That is on the Technology Day. And on 10th May, Delhi went on for votes for the general elections. So from a safety perspective, this particular award was not given. And then COVID came. So finally, this award was dispatched, but the ceremony could not take place. And of course, we were also finalists for the Kirkpatrick Chemical Engineering Award in 2019. This is the picture of the CSI Technology Award. Jitendra Singh ji, who is currently even today the Minister for Science and Technology. This is me, our IEP team. This is from Reliance, and Ajit Sapre from Reliance. Even Mukesh Bhai actually gave a Reliance Innovation Award 2018. This was adjudged as some of the highest impact and innovation. So final slide, actually, friends, I think it was a journey. Even today, when I think about it, in 2025, it looks like a dream of how we actually, from a very single, innocent-looking male from NSM to something that you saw, actually could not happen unless and until there would have been very sharp, focused research. Ultimately, the goal being to commercialize the technology rather than just to publish or have patents. So that was the ultimate goal. And I think more important is actually the synergistic, combination of chemistry, simulation, and engineering, which was brought in by this one team that I talked about, IAP and Reliance. And this could happen because of the deep and strong knowledge of chemistry. In fact, the US patent that you saw is a very unique patent which talks only about the chemistry of the process. In fact, the patent was given because of the chemistry part. The process modeling and simulation. And this actually was key because this actually helped to create confidence in the top management of Reliance to be able to invest close to 400 crores on something which is not commercially proven. And what is also required is multi-skill sets in terms of process simulation, thermodynamics, data reconciliation, and so on and so forth. And to be able to deliver not exactly a process design package, which was done by Technip later on, but a process technology information package. Which is the document which a company like Technip or EIL or UOP or any engineering company can then take forward to make a process engineering package. But the unique part of this entire journey was we actually did extensive documentation throughout the project. In fact, when the proposal was given to Reliance by IAP, we had actually identified 7 milestones, all the way from proof of concept to hand-holding during commissioning, as well as the guarantee test run. And each one of these milestones, we had extensive documentation. And to be able to meet targets at each TRL level, very strong, continuous, relationship with the stakeholders. Like we at IAP visiting Reliance, not only in Mumbai, but Jamnagar, and the Reliance folks coming to Dehradun. In fact, Abhishek was in Dehradun participating in the runs, carrying out simulations, etc. Listening, I think more important is listening to all the ideas, even if they are not connected. I think this was very important, not to give up against any odds. I think I think if you ask me, uh, my experience in my lifetime so far in terms of developing and commercializing 48 technologies that I've done so far, I think this one stands out because other than the technical part, the non-technical part in terms of competing with a foreign licensor and to be able to convince Reliance that to invest money based on this runs or experimental data and the package uh, was critical. And of course, you need self-confidence that if to be able to say that look, this will work. And I still remember that particular day when I came in for commissioning the unit at Jamnagar. This was sometime around 14th or 15th May 2016. I was called in by Saini Saab and Bala, and I didn't even actually enter the guest house. I mean, they told that Saini Saab wants to see you, and I went there. And they said that, look, do you think this unit will work? I said, look, this unit is already here for commissioning. I mean, why the hell are you asking? He said, well, actually, we have made some other plans as well. If in case bug, would you like to have a look? I said, no. I said that, look, don't worry about it. It'll work. I mean, that kind of self-confidence is required. And of course, all of this is 95%. 5%, you still need blessings from the Almighty. Because without that, I'm sure, I'm 100% sure things don't happen. So we need a bit of luck provided by our Creator. And that's it. Thanks. Of course, this is my old email address. You can ignore that. Yeah, that's it. That's it. And if you have any questions, I'm sorry I took a little bit more time, but if you have any questions, yeah, I'll be glad to. I'll be really glad to answer them.
Thank you very much, sir. We'll keep the floor open for question and answers, sir. Participants, you may please unmute and ask your questions, please.
So just this is Baliga from ex-Reliance.
Yes, Baligali.
I don't know whether you can see me.
Yes, I can.
I know about you. I come across your name and fame a lot, but I never happened to meet you. I was in Jamnagar and then left Jamnagar in 2012 and moved out of Bombay at that time. So never could see you. But I have been following this project very closely and I am very well familiar with all that you have said. Not the deep technical parts of it, but the broad business front. I understand this. The one question that even in the earlier phase I didn't understand is now why this benzene specification is fixed at 0.662. Why not 0.6 or 0.65 kind of a thing? Why from where this number 0.62 comes in the gasoline stream?
Oh, you caught me there. I also don't know where this 0.62 came from, but it is part of the MSAT 2 regulations, which was enacted by US EPA in 2011. I think it has something to do with the US refinery configurations and so on and so forth. I think there might be somebody else more knowledgeable on this who can answer Mr. Baliga's question.
Of course, NSM is not there today. Maybe when I meet or be in touch with NSM, I can ask. But there are others. Dr. Partha Maitra is also there, I think.
Sorry, come again?
I think NSM is not there today.
Oh, Murthy Saab could not join today?
Yes, sir.
There,
He is traveling, sir. He is traveling.
but I am happy to see Mr. Dr. Partha Maitra on this call. So,
Okay. So Partha can answer that. Hi, good morning, Partha. You've been keeping very quiet.
Yeah, it is your day. No, this 0.62 is actually it has to do with molar composition of the thing, which then in weight it becomes 0.62. So US has these quirky laws and regulations.
thanks, Dr.
Dr. Garg,
Hi, Mr. Ji. How are you?
hey, nice to see you.
Yeah, after a long time we are talking to each other. My
Yeah.
God.
You know that I am ex-IIP,
Yes, I know.
and I have been with you when you were director of IIP. So I have been wanting to meet you. Are you in Bombay?
I'm in Pune now.
Okay. When you come to Bombay, let us meet, please. I've got only one question in this. What kind of tray you have used in the distillation column?
Sieve trays.
Sieve trays.
Yeah.
Okay. And my congratulations to you for your outstanding work. And I'm
Thank
proud of IIP.
you, sir.
And you know that Jacobs Engineering, where I was Deputy Managing Director, we did the first phase of Jamnagar refinery,
Okay.
CDU and Vijay hydrotreater.
Yeah.
Yeah, go on, Lalit.
Good afternoon, sir. This is Bobby Raju.
Yes,
I'm ex-CPCL.
yes, I remember we met.
Yes, sir. I used to come there, and I think I was fortunate to just have.
Well, CPCL
your-
used to be my second home for a long time because we implemented advanced control from here.
Yes, sir. Yes, sir. Along Mr. The CN Vasudevan and all.
Yeah, Vasudevan.
Sir, this any economics has been worked out across this unit. How see extracting a kind of benzene out of FCC gasoline and separating benzene and also having the kind of gasoline of a low benzene content, whether it's a kind of any economics has been done in this because
Well,
FCC
actually,
itself is a good blending component for MS
oh yeah.
with reformate in the refineries configuration law. How this with the investment of 400 crores in the unit, whether did they do any kind of economics?
Yeah. Actually, no investment can happen without economics, as you know. This is actually This is I forgot to tell that this is the only grassroots unit in the entire Reliance world based on indigenous technology. And so very strong economics was done because of confidentiality reasons. I did not show that slide. But the payback, I mean, even if you look at the value of benzene in terms of the total benzene recovered from this unit, that itself, the payback is less than a year. So you can imagine the kind of, and for, not even factoring in the delta price between the actual treated FCC gasoline. That means the blending feedstock to the gasoline pool, having benzene less than 0.1% and sulfur less than 10 ppm. This is another thing which I forgot to mention, is that the raffinate that we produce from this extractive distillation process achieves the sulfur specification as well. So you don't need a post-processing unit like a scan finer or anything like that to be able to meet the sulfur spec. The economics is huge, and of course this unit is large. Currently, its design capacity is around 84,000 tons per annum. This is the design capacity of that unit, and today, of course, it is operating at 150% capacity. So if you factor in the advantage of having a low benzene and a low sulfur gasoline blending feedstock, then the payback comes out to be less than 6 months. We have carried out, I have all the data in terms of the commercial economics of this, but because of confidentiality, we cannot share that.
Thank you, sir. Thank you.
Just based on benzene, the payback is the year. If you factor in the FCC gasoline part as well, the payback comes out to be 6 months.
The sheer size of the unit, actually the economy of scale comes, there's a lot of benefit from the economy of scale.
Absolutely.
Such a large unit actually gives you so much of benzene recovery, straight away pays out.
Yes, sir.
Yeah. Perhaps in India, this is the largest extractive distillation unit actually. 4.5 meter diameter column. So, yeah, of course, economy of scale does happen, maybe goes a long way in terms of the payback. But I think even in smaller refineries, like for example, I think a good candidate could be the Indian Oil Corporation Paradeep refinery, where they have a 4.1 billion ton NMAX unit. There, of course, the light FCC gasoline, typically the same feedstock should be of reasonably good capacity to be able to put a unit like this with a payback of less than a year or 2 years.
Sir, actually, the benzene content in the pooled MS is a kind of a big constraint in the refineries.
Yeah.
So that being the case, reducing to the low levels of around 0.2% in that gasoline, the FCC gasoline, which is a major blending component in MS, definitely will be of much useful for refineries, I think, in achieving the final product slate and by absorbing more of reformate and improving the octane values also of the MS pool.
See, because there is no hydrotreating which is being done, right? It is just a removal of aromatics. The drop in octane is only 0.5, 0.1. And this drop in octane between the feed and the final product, that is the raffinate, 1 or 0.5 is also because we are recovering aromatics. Aromatics, as you know, is very high octane material. But rather than actually blending, and basically it is benzene, not even toluene. So that is something which is unique because it has very high olefins and isoparaffin. So the natural octane is high. And if you actually hydrotreat the benzene to make cyclohexane, you lose some olefins as well. And that will drop the octane. So it's a very unique technology that you maintain the octane while you recover the aromatics. And the bonus is to remove the sulfur as well. Of course, one thing I forgot to tell is that an extract hydrotreater was also installed to be able to actually remove the sulfur from the extract. And that after removing the sulfur, that stream was then sent to the ED sulfurine unit in the paraxylene complex to be able to recover the.
In fact, in CPCL, we have kind of NMP extraction unit for making hexane from the straight run naphtha.
That is in HPCL.
Yeah. Subsequently, we have taken that kind of a C6 hard cut naphtha from isomerization unit, and then that is become a kind of good potential for making hexane.
Yeah, I know.
Which is a kind of relatively high value product compared to that of OMS. I mean,
yeah, that is a petrochemical grade hexane that you're producing. That's basically a side product from the divided wall column.
Yes, sir. Yes, sir.
Yeah, actually, I remember that project. Actually, I was at IIP. In fact, your old reformer, the semi-region reformer, was converted to an ISOM unit, right?
No, CCR. Semi-regenerative
CCR.
has been converted to
CCR.
CCR,
Okay.
continuous catalyst.
All right.
For first of its kind in actually in Asia.
Yeah.
Second in the world, subsequent to Greece, they have done it for first time.
Yeah.
Accents design.
Yes. In fact, that hexane is very good quality. Actually, it is being used in Reliance also in Jamnagar. The one from BPCL.
I have a question on this water circuit that you showed, a very complicated water circuit you talked about.
Yeah.
I'm just wondering whether was there any further scope, or is there any further scope for optimizing in the process design, like a single column, which keeps both different types of waters segregated and optimize on energy and separation. Why I'm asking this question is if the more number of columns and strippers and units are there, then the complexity of the unit goes up. And then so much of operation and maintenance and operating manpower and so on and so forth, so much complexities goes up. It would have been a more ideal situation if the two units are combined into a integrated water circuit where the waters are kept separate, but the mechanical equipments are integrated.
No, you're right actually. But I think if you try to compromise on handling water in this unit, three things happen. Number one is you tend to actually lose. See, basically, solvent is a polar material, and it is highly soluble in water. And so actually, if there is any loss of solvent in the entire unit, that is from three sources. Number one is the dissolved solvent going along with the raffinate, dissolved solvent going along with the extract, and if there are any water leakages, etc., in the unit. Now, what happens is that all the three have to be controlled. Okay. Let me actually, I think, just a moment. I just wanted to bring up that flow sheet once more. Go. Yeah, let me actually show you that flow sheet once more. See, if you look at, I talked about the solvent loss along with the raffinate, right?
Yeah.
That we are controlling by actually washing this overall overhead stream with water. So there's a complete mixing of this overhead raffinate stream with this water. Remember that 85% of the feed is this raffinate. And if even this contains 10 ppm NMP, which should be okay from a gasoline blending perspective point of view, but still actually it's a large amount of solvent being lost. So
Yes.
what we did was we actually brought this water from the SRC overhead, from the SRC stripper, all the way to the column top and mixed it so that we don't lose any solvent along with the raffinate. Now, the other source is this extract, okay? But actually, there's a large amount of steam which is being put here in the SRC, which is actually generated from this water itself. So that goes up, and when it condenses, along with the aromatics, it actually dissolves the solvent out from the aromatics into water. And then actually this extract becomes less in NMP. Now, all this water which now contains NMP, we need to actually handle it in a very efficient manner. As far as the operation part is concerned, this is completely automated. In fact, if you look at it, this is the PFD. So this is the process flow diagram with all the control systems, etc. And now actually this unit has been put on advanced control. So there's no problem in terms of operation. Remember, this unit has ran for 7 years without a shutdown. And as far as the strippers are concerned, this is actually pretty mild operation. It's actually, if you look at, the feed coming into the stripper, that is mostly water with a very little amount of hydrocarbons. So this system is full of water. So there's nothing in terms of any blockages or actually heat exchangers being choked and so on and so forth. And also this is running free because we are using the hot circulating solvent to run these two. If we wouldn't be running these two, then our fin fan cooler duty would have gone up. So actually, these are being running for free. So actually, managing water in this kind of unit, and particularly with NMP, because we had to optimize the water content in NMP. Because I mean, this part is actually discussed more in the patent that I showed. But there's a certain percentage that we need to maintain, which actually gives optimum performance in terms of benzene in the raffinate and the percentage aromatics in the extract. I hope that answered your question.
Yeah. Fine. Thank you. Thank you, Doctor.
Venkat BTM, sir.
Sorry?
Mr. Venkat or Mr. VTM, sir, would you like to add something?
Congratulations to the team and Dr. Madhukar for an excellent presentation.
Thank you.
We're really proud of you, sir. So
Thank you.
I'm not technical to ask any questions, but I think somebody asked about the economics and you
Can I
answered.
ask a question?
Yeah.
Can I ask a question?
Yes, please go on.
Dr.
After Mr. Venkat speaks.
Excellent
You can carry
presentation.
on. Yeah.
Excellent presentation, Dr. Madhukar. In fact, I've been with the Aditya Birla Group, but I need people like you, the younger generation, next generation, to develop our own technology and then export instead of depending on imported technology. I think yours is an example of proving that we have the capabilities. Like we do in IT, I think in chemical engineering also we should establish our supremacy sometime. I hope the younger generation will take it up. Thank you so much.
No,
you
I think
see,
you read my mind, sir. Actually, we do have the capability. I don't think we can say that we are less to anybody. I think it's a
Yeah.
matter of actually identifying people in terms of the science, in terms of technology strength, like-mindedness, and more importantly, the urge to achieve something and to commercialize. In fact, before I left Reliance, I had initiated discussion with large number of engineering companies, and one of the major licensors was interested in licensing BRU worldwide.
Yeah.
So I hope at some stage Reliance and IAP would be able to take advantage of that effort that I had put in when I was in Reliance to be able to license this worldwide. But let us see, time will tell.
No, it's a great effort. In fact, in Chennai, from ICC point of view, we are trying to coordinate with the universities and the industry so that you see the research what they do, it becomes commercialized. So that is where we should focus. I think the younger generation will take it up. Thank you
you
so much.
see, Dr. Garg
Yeah.
belongs to the younger generation only.
Yeah.
Yeah. I mean, age is only a number,
Uh,
boss.
I am now 80, and Dr. Garg much younger to me actually.
Yes.
And my question, Dr. Garg, was that who is the engineering consultant for this project, and if IOC Paradeep wants to use this technology, whom they should approach?
I think IAP, if they can approach, that would be ideal. The engineering company which actually did the basic engineering package and as well as the extended basic engineering package was Technip in Delhi. And we actually handheld them in terms of making them to understand what exactly we have done.
IIP's office in Delhi is still there?
No, no.
Because during my time, there was a project office of IIP in Delhi.
Yes, that was closed way back in 2004, I think.
During Prasad Rao's time.
After Prasad Rao's time. No, not in 2004, because 2003 I took over as director. That office was still there. Yeah, it was closed in 2004, 2005 time frame.
So IOC can approach IIP for the technology of this unit.
Yes, in fact, IAP currently the director is actually former Reliance guy itself, Harinder Bisht. So we have a industry guy actually heading IAP Dehradun. In fact, as you know, Mishraji, IAP has been a very, very unique institution, a CSI lab in the CSI world, where most of their directors actually, by most, all their directors came from industry. So even the current director is also from industry. So I think that helps actually in terms of trying to understand and then taking it all the way for commercialization.
No, I know that because I am seeing IIP from the days of Dr. Krishna. And
Yes.
so I am talking pretty old situation. And I am always proud of the achievements of IIP, being
Yeah.
myself from IIP.
In fact, Prasad Rao came from IPCL, and then there was a small stint when Sudhir Singhal was director. That was only for 3 years, and then I took over. And then I was succeeded by Anjan Ray, who came from UOP. And today, of course, we have Harinder Bisht. Hey, Paddy, are you there? I see S. Padmanabhan here on the list.
So this Padmanabhan is from Kempla Sharma, sir.
Oh, okay. Because I knew one Padmanabhan from BPCL who was also managing director of Numaligarh Refinery. I thought he was there. No? In fact, that was another project which is of the same league as this one, where we put a 60,000 ton per annum wax plant at Numaligarh Refinery, which actually turned India from a net importer of wax to a net exporter of wax to 32 different countries. And that's a very unique unique piece of work that was done.
Dr. Garg, this is Ashraf. I think one question you already answered, that Reliance and IP are trying to get this technology to other users. Um,
Yeah.
is this like something which been? Is there any reason why, even after having 7 years of successful operation, is it a kind of resistance within the team that they want to first make sure everything is okay before they come up, put it to the other people, or is just the dynamics of the way the world is moving? That's the question. Second thing, I think NMP was the best solvent which IIP and Reliance came out. Has any further work has been done to, let's say, if we put some additive in the solvents to improve or reduce the solvent ratio to make it more efficient, the whole system? Basically, a question, is there a continuous improvement being done to see whether we can go stretch the system a bit further?
Yeah, there were two improvements that we had done. Of course, I'm not aware whether IAP is continuing any further development. I totally agree with you that that activity should continue. But in Reliance, after I joined Reliance, what we did was we actually installed uh, an adsorbent to actually put a slipstream of the solvent through these adsorbents to be able to reduce the chloride and the tan, the total acid number, so that because these kind of build up over a period of time. So actually that reduced the drumming, the total amount of drumming of the solvent also significantly. So that drumming means to be able to to withdraw some of the degraded solvent. So that is one innovation that we did. There again, some studies were carried out at our R&D center in Baroda, and based on those studies, the unit was designed indigenously within Reliance and then installed in Jamnagar. So that is one innovation that we did. The second innovation was in terms of trying to actually see how far we can stretch the unit in terms of reducing the solvent to feed ratio, etc., etc. And I think there's not much room left now to drop the solvent to feed ratio further. It's almost down to 60% of what it was earlier, and still handling the same feedstock. So that I do agree with you that there is still room for adding or innovating some additives which can actually help to reduce the effect of chlorides as well as the tan. So that can be done. To answer your first question, with 7 years plus of successful operating experience, why aren't we actually ready to license this technology worldwide? Well, actually, I was right on it even in 2012, 2013, when there was an opportunity in South Korea, which actually I discovered. And I was trying to push it there. But then I think in Reliance, there was some inhibition that let us actually, first of all, commercialize our own unit and then see. So after the commissioning of the unit, fortunately, I joined Reliance, and then I started personally look at it to see to link up with a major licensor. We did that, and I've been pushing it through the system. But actually, the thing is that company like Reliance is a manufacturing organization, and maybe they don't see a kind of uh, incentive in terms of licensing a technology. So that is where actually I feel the pushback is. But nonetheless, I think I leave it to now Harinder and the current management of Reliance to be able to push it further, because all the paperwork and everything is done to take this major licensor on board.
Okay.
Uh, yeah.
I think it's not a very uncommon for an operating company to own license. The best example, ExxonMobil Phillips 66, Chevron, they themselves have
Oh,
come
yeah.
out, developed process, and then started marketing outside their own domain. If my understanding, maybe you are a better person to answer the question. As of today, it's just this process, and there's another competitor who, if I'm not wrong, is using a different solvent for the same benzene extraction from FCC gasoline. So the space for competition is pretty little. So the opportunity is pretty good. So that's something as a commercial guy I would be looking at, that you have such a thing, and for sure getting in onto with the existing FCC licenser, the
Yeah.
chance of it becoming successful is much higher than that's doing it on all on own basis. That's what other person has done, if I'm right.
That's what I did actually. I linked up with the existing FCC licensor itself.
Mm.
And in fact, this is one piece that was missing in their entire technology roadmap. So they were seriously interested, and I don't see any reason why we should not do this,
Yes.
because it has a lot of advantages actually. People within the company start actually getting experience of how to develop and license a technology. See, this is something which is very important.
Yeah.
Ashrafji, a lot of people don't realize, particularly in operating companies, that it takes a different kind of a metal to be able to convince others about your own expertise.
Yeah. Yeah.
And we know that companies like UOP, Technip, Accents, Lummers, we blindfoldedly accept that their expertise. But now, why not us?
But if you look at most of the big licensing company, the top peoples are Indians now. So
Absolutely.
so if we can do it sitting there, why can't we do it sitting here? That's the challenge I'm trying to understand. Like
I
why
don't
we are
see
so
the risk
shy
involved.
about our success.
I don't know. I mean, no, it's not that actually. I mean, believe me, when I was at IAP, we actually developed and commercialized technologies worldwide.
Yeah.
That
Yeah.
SABIC
Yeah.
is one of the major beneficiaries of IAP.
Yeah.
SABIC in UK, major beneficiary. They were going to shut down their sulfurine unit, and we came and then actually revived it. Not only that, there are many things that we have done for SABIC and many companies worldwide. But there actually, because we were confident in what we were doing and it will work. Well,
Yeah.
I don't know how to explain this. Which
Yeah.
company do you come from, Ashrafji?
Garsab, we have met a lot. I'm Ashraf Lakha. I used to work
Ah,
for Coglish, and then we bump into each
yes,
other.
yeah, we met in Singapore. Yeah, yeah,
We met in Singapore. First, we met in Gale, Guna, when you
yeah,
were still with Technip for the pinch analysis technology head.
yeah.
Yeah.
You know
Yeah.
that this other company that you mentioned about is kind of. So let's talk.
Okay, no problem. Thanks,
And we
thanks a lot for
mutual
the
friend,
great.
Manish Bhargava.
Yeah, thanks a lot for sharing such a interesting license technology, which I'm sure everybody in this forum will appreciate. And we hope we can become ambassador to push this and talk about when we meet our cohorts in other companies.
In fact, since you talked about it, Ashraf,
Mm.
just for the audience, this particular project actually made me experts in many areas. Not only, of course, this is of course extractive distillation and extraction. This is something which is up my sleeve anyway. But something I did not know, like the entire Indian patenting system. So that actually was a big learning curve for me. I mean, this project actually made me an expert on patents. Also, the RTI, Right to Information Act. I thought it was just a piece of paper, RTI, but actually, this particular project being made me an expert on RTI as well. So there were many things actually which helped me. In fact, just to quote our great guru, Professor M.M. Sharma, when Reliance accepted this technology, Sharma ji called me up. He said, Madhukar, now you've graduated from playing a village cricket to an international cricket. And coming from Guruji like Sharmaji, I think it's a real compliment. Yeah, so
Thanks, sir. Thanks for sharing this today. Appreciate.
thank you, thank you.
Sir, Pradeep Kumar here.
Yeah.
So regarding the sulfolane unit, the chloride, we also tried using the known absorbent. I think I think we had briefed you when you had come to visit us.
You mean
And
OMPL?
yeah, OMPL.
Yeah.
Yeah, right now I'm not in OMPL, sir. I have moved out.
Okay.
Moved out to Middle East.
Uh-huh.
And the one important thing is the basic chemistry which we used for converting this chloride is injection of water. So when we inject water, we use the DM water injection. The boot water will start accumulating the chloride, whichever is the inorganic chloride that comes out. But the organic chloride doesn't come out.
No.
But the inorganic chloride we got it, and we had a talk with you when you are in Reliance about a process for cleaning the system. But at that time, our chloride in the circulating solvent was around 300 ppm. So by injecting water, we had brought down the 300 ppm to 25 ppm. I think this I just wanted to share to people. This is our innovative work. So it's just a chemistry that water can carry the chloride when you start injecting it. This is one thing I wanted to contribute in this.
Yeah, actually, but when you drain that water, na, Pradeep Kumarji, you lose a lot of solvent in that.
No, sir. Actually, we try to see that whether we get solvent in that or not. But I think it is a controlled way of doing it, sir. That's
Okay.
what we found it. You can also try this in the existing unit, a controlled way, not more than I think not more than 2 liters per minute, not more than. It
But
will
somebody
take
said
time.
that OMPL unit is working well now.
Yes, sir. Yes, sir. We could achieve very good separation. The only problem we face is the C7 that comes to the C7 straight chains. They don't come out from the sulfolane loop. The oil accumulates 1%. 1% is also very tough for us to remove. What we found is another source that is in Maharashtra, MEPKL. Mr. Samir, he's Banerjee, he's doing it. We send the solvent there, and he uses the distillation column to separate it and he gives back us a pure solvent and the oil and water separated.
Yeah, he's the only guy doing sulfolane for everybody.
Yes, sir. Yes, sir.
In Taluja, right?
Sir. Sorry.
Uh-huh. No, but this particular thing can be overcome.
Okay, okay, sir.
One last question before we let Dr. Garg. Anyone else has a question, you may please unmute and ask. One last question we can take.
So slightly a digression, but there is a lot of emphasis on methanol as a sort of a green fuel development. So how is as a country, how are we progressing on that? And especially with the strides that China has taken with underground coal gasification and then methanol initiatives. Is there any sort of roadmap in view of the green fuel transitions on this? Sorry to digress, but just thought the expert panel over here could be.
Well, if you want my views on this, actually, Dr. B.K. Saraswat at Niti Aayog has been trying to push what he calls as methanol economy in the country. And that was initiated way back in 2014-15 timeframe. There was another large conference that was held sometime in, I think October, November this year. Sorry, last year. Where he brought in a lot of stakeholders to be able to push methanol. What I understand is that it has been successful to some extent, particularly in the marine industry, where actually the ships had been very happy to take methanol. But green methanol is something that we need to look at seriously. When you talked about coal gasification or underground coal gasification, that still doesn't make methanol green. What is required is, of course, biomass gasification, then to make syngas, and then from syngas to methanol. And then, of course, in today's context, there is more incentive to convert methanol to jet fuel. That is the sustainable aviation fuel. So actually, it's a very complicated topic. Everything looks great on paper, but ultimately, to be able to make it commercially viable is something that almost everybody is trying to look at. Because it's not just something like methanol from natural gas. And to be able to compete with the price of methanol from natural gas uh, is uh, is something which is very, very difficult. Uh, so we need to actually have a system in place, either in terms of carbon tax or in terms of government incentive, to be able to incentivize the production of green methanol, or for example, e-methanol, that is carbon dioxide captured from atmosphere, and to use green hydrogen. So it's a very complicated subject. I think we can have a general discussion at another forum on this, and this particular group is ideally, we have all kind. I mean, we have the really large intellectual people here, which we on which we can brainstorm really. Um, yeah.
Thank you, sir. Thank you so much.
I don't have a straight answer to you, but because almost everybody in the world is looking at these aspects. Uh, of course, ethanol is another one which has actually gone very far. And as you know, we are already blending 15% ethanol in gasoline, hope to get to 20%. But there are other routes because ethanol to jet fuel is already something which is approved by ASTM. And there are many companies who are actually, companies like Lanzatech, etc., who are actually have the technology to convert ethanol to jet fuel. Um, and of course, as you know, the companies who have actually recovered or converting waste gas from steel mills, etc., to ethanol. So all in all, I think ethanol seems to be a better prospect right now to make things happen in a more nearer future uh, as compared to methanol. I mean, this is of course personal
Dr.
view.
Garg, can I reply this question?
Yeah, sure. Yeah.
I have been in coal gasification since 2012 as the advisor to Jindal unit in Orissa for the synthesis gas which goes to DRI plant in the steel mill. And at that time, we had a visit to China. And in China, you won't believe, they gasify almost 1 billion tons of coal and they produce 32 million tons per year of methanol. And India at that time was closing down methanol plant of Deepak, for example, closed down. The only methanol plant that is running is GNFC and Assam Gas. And in my company, Jacobs, we were specialized in methanol plants, steam reforming of fossil fuel, and for this. So the question is, and methanol today has lot of diversification to methanol to olefins to methanol to the other chemicals. So methanol becomes a kind of a basic feedstock for many industries. So, but India has never ever tried in an aggressive way in going for methanol, which Dr. Saraswat is trying, and there are some government schemes have come for large scale subsidy to coal gasification plants, and I hope methanol will be a product of that actually.
No, I agree with you. Actually, there are 3 or 4 projects funded by DST. I'm a member of that committee. Actually, there's a pilot unit which has been set up by Thermax in Pune, as well as by BHEL in I think Hyderabad or Trichy, one of the 2 places. But yes, yeah, we don't make much methanol in India anyway.
The last plant Jacobs built was a 5,000 ton per day methanol at Salalah in Oman actually. And today methanol plant's capacity is not less than 3,000 tons per day, economic capacity.
Yeah. I think Oman was 7,000 tons per day, right?
Yeah.
So I think there is a good deal of scope to take this forward, especially in view of the kind of coal reserves that we have, which has no other potential. Well, you rightly said about the green methanol, but I think that could lead the way to the green methanol as this could be the initial stage for commercialization. And for the kind of capacities that China has already sort of brought in, the scale and cost competitiveness is established.
No,
So
in fact, I saw a smaller plant in Canada from Bio West, a 150 tons per day methanol plant in Canada, Edmonton, given by technology being given by a company called Innerchem actually, which is now that technology has been owned by Technip, and so Technip is also giving the same technology for methanol manufacture from bio waste.
Bio waste.
Uh,
So
the
that is gasification of bio waste or pyrolysis.
pyrolysis.
Yeah. But that will make fuel oil. I don't think you can convert pyrolysis oil straight to
No,
methanol.
sorry, I am sorry. That is gasification.
Yeah,
Gasification to syngas and methanol.
Yeah. But if you have coal gasification, etc., you still have to worry about scope 1, scope 2 emissions actually. Because any gasification plant converting coal to syngas and then to methanol, ultimately you have to do the carbon balance.
Now you can make CO2. They are making CO2 to methanol actually.
Yeah.
One commercial plant has given by Halder Topsoe,
Yeah.
So I think NTPC also has recently gone in for a methanol plant at one of its thermal power plant. It is, I think, still a sort of a R&D pilot kind of, but I think, with the carbon balancing aspects, these feasibilities need to be evaluated.
Yeah, they don't talk about it, but actually the catalyst and the pilot unit was developed by IAP. And yeah, in fact, I had more or less initiated that project with NTPC when I was there. I took some time to actually bring up to that stage. The pilot unit was set up at IAP Dehradun, and then they took it away and put it in Netra. Netra is actually the R&D arm of NTPC. So they're actually CO2 plus hydrogen going to syngas. That is the technology that IAP developed. I think it's a catalyst and the operating conditions which are critical to make that happen. So that is again IAP's work actually, what NTPC has.
Nice to know. Thank you, sir.
Right, sir. So thank you very much, sir. Thank you very much for sharing your wisdom today.
Thank you so much, Gopiji.
We had a lot of takeaways from it. And probably next time when I travel to Pune, I'll definitely get in touch with you, sir.
Yeah, thanks for the opportunity, and it was a
It's a
very,
pleasure.
very involved and interesting discussion following the presentation, and I could see some of my old friends in the discussion. So that is actually double, happiness to me. Reconnecting with them.
Thank you very much. Mr. NSM could not join because he was traveling back from his hometown, sir.
Okay.
He just sent me a text now. He was not able to get a signal as he was traveling.
Well, he has been a champion of this from Reliance side. I must say that he had the unwavering, what I should say, confidence that we can do this. And in any technology development work involving a research lab and the industry, and in our country, we talk a lot about industry academia interaction and collaboration and so on and so forth. And this, I've been hearing it for more than 2 decades now. But this is how you can make it happen. Actually, you need a champion from the industry who believes in something which can be done, and pushes that cause within the company actually. And NSM actually did that. I don't have any words to thank him for that effort that he had put in. If without him, I don't think we would have been able to possible to come to this level. I really missed him today in the call.
Yes, sir.
All right.
Thank you very much, sir. Thank you once again, sir.
Thank you so much. Thanks everybody.